Okay. So let's go to here. Okay. So in today class, we can discuss how to create a cluster and how to run basic commands. We can understand. Okay. Kubernetes commands are very easy commands, guys. Docker nodes. Okay, I'll share. Can you check in the Google Class Meet? I think Google Classroom I have shared Docker. Not shared. Huh? Okay, I'll share it. I'll share it. Definitely I'll share it. Okay. Okay. So first we can focus on EKS, Elastic Kubernetes Service, a service in AWS. So you can open here. Yeah, Elastic Kubernetes Service. Okay. So guys, yeah, the main problem with cluster creation process is a plural set they have uh, earlier I used to follow the CLI commands to create a cluster, just testing purpose first. Later we can implement through Terraform. So this is just focus on create a cluster with existing environment, existing VPs and subnets and all. Through Terraform, we can plan production ready cluster. Everything we can manage by our own. Focus is cluster concepts, no, not how to create a cluster. Okay. So by default, we can take existing cluster, existing environment cluster. I mean, existing VPs, existing subnets and all. Even a single command is enough to create a cluster. But unfortunately, Pluralsight, there are some restrictions enabled on CLI user level issue. I mean, restrictions to create a cluster. So that's what we are creating a manual, console process. We have raised the request. They're working on it to fix the issue. Once issue got fixed, we can easily create a cluster by giving a single command only. Understand? Anyway, but final process to create a cluster is Terraform only in real time, right? We can discuss through Terraform later. Meanwhile, we can create a cluster manual process. Okay. Let's try manual process. I'm also new to this process. So quick configuration EKS auto mode is there. Na? I mean, when you create a cluster, you can go for custom configuration option. Don't click auto mode option. Okay. And this toggle is enabled, right? You can disable this. I'll discuss what is auto mode and all. Next, let's check here. Quick configuration. With EKS auto mode. No. Give the cluster name anything you can give. Uh, cluster IAM role. So we have to create a role first. So the document I will share, guys. 4 or 5 steps are there so that you can go through it. So I have shared already. Okay. So cluster permissions, you have to create a IAM role behalf of EC2, and you can attach this IAM role to, uh, you know, cluster. So open EKS AWS console services, Elastic Kubernetes service, create a cluster, cluster basics, give the basic configuration, go for demo. Any name you can give your wish. And version you can select 1.29 above, 1.30 or 1.31, anything is okay. And turn off auto mode is very important, otherwise it will be cancelled. And the configuration base EKS auto mode toggle should be off, just now I did. And coming to the networking area, choose VPCs, subnets, and endpoint enable public access, unlock, uncheck all the locks. Okay, okay, okay. So this is keep as is. And let's go to here. Yeah. Okay, let's go here. Anyway, let me explain here. So guys, here this role we have to select the cluster IAM role to allow Kubernetes control plane to manage AWS resources on your behalf of. This cannot be changed after cluster is created. To create a new custom role, follow the instructions in the AWS EKS user guide. Okay guys. So guys, this cluster once we create, we can operate from the EC2 instance client. So we can create a one IAM role you can attach to EKS cluster. Same role you can attach to EC2 instance. It will be communicated and we can access. Many concepts are there, guys. It's not possible to say in one word. Coming classes will get a clarity. Mhm. So I'm going to select here EKS. Okay, cluster level permissions. Next, I'm giving here EKS cluster policy. By default, it is selecting OK. Next, role name is EKS. Create a role. Clear now? And again, come to here, refresh. You can see your EKS. Clear? So you can create recommended role with this option. Otherwise, you can go to IAM role and create a behalf of EKS and give a permissions. Version is what? 1.34. Okay, leave it. And yeah, you can uncheck all the options. Yeah, keep as is, everything. But where is the VPC selection here? Here. Maybe next step. Okay. So default VPCs, default subnets, all are I'm selecting, and default SG also. Cluster endpoint access, give public. Yeah. Next. Yeah, you can uncheck. You no need to select anything. Next. And you can ignore all the things. Next. And next. Go next. You need to select everything. By default, we are doing default one. Okay. So guys, first cluster is creating. Okay. Let me show you the thing here. So EKS cluster, Kubernetes cluster. Cluster means combination of control node and worker node. Cluster means RDS cluster means what? Combination of master and readers, right? So we have a control plane here and we are creating a worker nodes also. So here, very important thing we need to understand here. This is control plane or control node. These are the worker nodes. Okay. This is worker node. Clear na? Okay. So I'm creating a cluster now. Okay. The point is how to access this cluster. If you create from your laptop by configuring the access key secret key by running a CLI command, yeah, cluster you can access from your laptop. But if I create a cluster from EC2 instance, I can access from EC2 instance. Now, whatever role I have attached, right? EKS cluster, this role, if I create one EC2 instance, if I attach this role to this server also, this server able to access control plane. Okay, let me explain. Wait. It's a creating. Just wait for few minutes. It will take time definitely. So guys, it will take time, 25 minutes to create a cluster. Some cases 40 minutes also. Anyway, uh, we have an option B. Meanwhile, we can practice Kubernetes environments, commands and all. We have the concept is Killer Coda. It's a free environment. So you can click on playground here, killercoda.com. So you can see Kubernetes 1.34 is there now here. Kubernetes playground. You can take anything if you click on it here. Sign into Killer Coda. So GitHub, you can configure with the GitHub authentication. Voice echo. My voice is clear now. Can anyone please confirm? No, fine. Thank you. Okay. See, environment is creating. Guys, this is just a practice environment. Understand? So today we can practice few commands for the Kubernetes. So manual process to lengthy process. We can go for Terraform only in the real time. I'll show you how to do it through Terraform. Unfortunately, CL is not supporting some issues there. We have raised the request. We'll see. So definitely it will take time, guys. So meanwhile, this one also taking time. Why? Wait for some time. Start. Let's restart. Waiting queue. Let's click on it here. Wait for some time. It should connect quickly. Your end is working fine. Then why my end is taking time? You guys end is working fine. Yeah. Cluster is active right now. So guys, click on the cluster. Here, here the important part is now, if you go to North Virginia EC2 level, I couldn't see any instances here. Clear na? Okay. Now what we need to do after create a cluster, click on the cluster here. You can see compute. Click on the compute. Node group is there now. You have to create a node group. You can give node group name is something you can give here. Same. IAM role, you can go for create recommended role again. It will select EC2 by default. Required permission. Okay, let's give a administrator permission and give a role name is EC2 to admin node group. Something you can give. Create a role. So role created. Let's go to here and select the created role here. And now next on demand and instance type. Which instance type you want for the worker node? I'm taking T2 medium. So desired capacity, how many instances required minimum maximum? I'm go for 2. Means as of now we'll create a two instances desired capacity. So these nodes can create any one of the subnet like RDS we are selecting, right? Next, create it. This will take more time. Okay, guys. Now how many nodes I'm creating now? 2. Clear na? T2.medium, T2.medium. Okay. Okay, why? Let's log out first immediately. Let's re-authenticate again. Let's try 2 GB, 2 nodes. Okay. So guys, you are inside of control plane now. So each instructions will go to where? Control plane or worker plane? Control plane. Each request will go through control plane to worker node. Clear na guys? Control plane to worker node. So here control plane inside how many components are there? API server, scheduler, controller, etcd, right? So first request will go to where? API server. Clear na guys? Now first command is all commands start with kubectl only. Kubectl or kubectl name. Okay. Docker, all commands start with docker. Kubernetes, all commands kubectl. OpenShift command is what? Anyone remember? OpenShift. Kubectl get nodes. How many nodes are running? 2 nodes. Okay. I think OCI, OpenShift controlling interactor. So kubectl get nodes. So how many nodes I can see here? 2. One is control plane, one is worker node. So guess control plane is whose under it is? Killer Coda. Platform provided by Killer Coda, right? Not AWS. This is not AWS. So you can see control plane plus node also. But when you practice an EKS, you can see only worker nodes. I clearly mentioned yesterday, right? Control plane responsibility will take care by AWS. But your instructions will go to background AWS control plane. From there, it will be redirected into worker node. Clear now? So easy commands. If you want to get a pods, nodes, everything, the instruction is kubectl get only. Pods means pods, nodes means nodes. Nodes. How many nodes are there? 2. 1.34 point version is there here. If you want to check pods, no resource found in the default namespace. Meanwhile, let's discuss what is pod and node. Sorry, pod and container. So guys, let me add one layer. This is a container layer. Container inside, what we have? Application, right? Application create from where? Image. So can I add like this image application container? Okay. So this image application container. Clear now guys? What about pod? Pod is a layer on top of the container. That's it. Understand? Pod is a layer on top of the container. Simple. Why? What is the use of this layer? This layer can help to communicate Kubernetes. Kubernetes creating pod, right? So this layer will additional layer will help to communicate the Kubernetes instructions. Container only can work Docker commands. If a containerization platform Docker you can use, Docker instructions will go to container. But this is created by Kubernetes. This layer will help to communicate the Kubernetes only. Understand? So abstraction layer of content on top of the container. Container is pod. Pod is lightweight or not? Yes, of course. That image is having a less dependencies. Pod is lightweight. Anyway, so I'm checking now. kubectl get pods. Any pods are there? No. Clear na guys? Node group still creating. Oh, ready. So fast. So guys, two nodes are ready, right? These two are worker nodes or control nodes. Clear, right? Okay. Now I want to access this cluster now. So simply here I'm running a kubectl get commands, right? Here I'm running in the clear code inside kubectl get pod, kubectl get nodes, easy way, right? Now, where I want to run the commands? Anywhere, laptop or inside the EC2 instance, right? For example, I'm creating a one server. So guys, here how many servers I can see now? Two servers. These are worker nodes created by Kubernetes. Here one node is missing. Control plane is missing. Control plane taking care by cloud. So now how you can interact this? You need any one environment, server or any environment. The request should go to control plane, right? So what I'm going to create, I'm going to create a one server here. Client. Can I say client server? This is from where you can interact the cluster. Client server. Um, launch server. Okay, so my server is running now, right? So I can connect this server fast. Hello? Hello? Okay, so guys, here, let's check this SG now. Hmm. Okay, let's connect the server now. Guys, this server is just, it's not a control plane. This is a client server from where you can interact the cluster. Clear now? Don't confuse. This is not a control plane. This is client. I'll show the architecture. Wait. Hmm. Sudo su hyphen. So guys, if I want to perform Kubernetes commands, you have to run kubectl, right? If you give this command not found, kubectl package is missing, right? You have to install first kubectl packages. Okay. So go to here, Kubernetes repositories directly. Day one installation. Many things are there, guys. One more time, I'm saying Kubernetes is, it's not to complete in 1 week and 10 days and 15 days. Okay. So here I'm installing. Excuse me. So I'm installing here kubectl commands. So now can I run kubectl command now? Yes, clear now. So can I run kubectl get pods now? How? How this server knows to go Kubernetes cluster? Understand or not? First permission required or not? So I created a cluster by using cloud username, right? These credentials, right? I have to configure first credentials. Where to go? Here, access key, secret key. Otherwise, role AWS configure. I will explain this concept. This is authorization authentication concept is in Kubernetes. By default, Kubernetes is not. For example, if you try to connect from the different servers to the Kubernetes cluster, it will not allow. Kubernetes inside we have to add a RBAC process is there, role-based authentication control. We have to add inside user information or role information to access cluster from different environments, different servers. So AWS configure here. Cluster created on by which user? This user. That's what I'm configuring the same keys here also to get access. US East 1. Clear na guys? Still issue is there. What we can do, you can run this command, update command. To run this command, again problem will come. ECase command not found issue will come, right? Okay, ECase by default will come now. Okay. Name of the cluster is Vera. Region is US East 1. Add a new context. So you can see root home directory inside .kube inside one config file updated, right? So it will authenticate your cluster. So your access key secret key match with the cluster created user. So you are able to connect now. Okay. Let's run kubectl get nodes now. Huh. How many nodes are there? I can see two. These two are worker nodes only. What about control plane? It's not our responsibility. Clear now? Okay. So let's move to here. So I created a cluster. Now how to access a cluster is a point here. Understand here. This is managed by AWS. Okay, this is managed by AWS. So I created a one server. So this is not a control plane. This is client. Clear now? This is client. So where we can interact the cluster. So if you run any commands, request will go to background control plane. From there to worker node. Clear now? Now this server authenticate this cluster by access key, secret key, or IAM role also. We'll discuss in the coming class. Okay, now guys, point is here. Can I access from my laptop? Why no? If I configure the keys, I can access or not? AWS configure. Now, if I run kubectl, first your and kubectl should be there in your laptop, right? Same command you need to run ecase kube config update command, which I ran here to update the .cube authentication. Clear now? So I'm sharing this command with you. Okay. So now run kubectl get nodes command. Clear now? You can run from anywhere, doesn't matter. But here user keys, access key, secret key. You can also run from your end if I share the keys. Okay. So till here clear now? Okay guys. So let's get started now main process. So guys, kubectl. Okay, clear the screen first. Yeah. So guys, in Kubernetes, we have a AML files. Every instruction we can pass through AML only. So what you can do in today class, you can ignore the AML how to write. First focus how the concept is working in the background. Then tomorrow class, we can focus on the AMLs how to write. Very easy AMLs, nothing to worry also. Okay. So today focus is not AML file. Focus is how this background it is working in the architecture background. Okay. So guys, we have a three type of major AML files for the application deployments. One is pod, one is deployment, one is replica set. Let's write. So in Kubernetes, we have a three type of major AML workloads. Workloads. The main thing is three. One is for pod, and second is for replica set, and third is for deployment. Okay, these three are the main workloads in the Kubernetes. So these three run inside the worker node components only. Here only, here only, here only. Clear now? Let me run a pod.ml. You can take a basic pod.ml. So you can take from Kubernetes official document also, my GitHub also. So official document, this is very good documents, guys. Kubernetes.io. You can get it everything from here only. Kubernetes.io. Like Terraform, how we have taken reference from the Terraform.registry, same. What is pod? A pod is a lightweight object, smallest deployable unit, right? Yes, deployable unit only. Inside only we can deploy the application, right? Mm. So pod is a it's a group of one of more. You can create a multiple container also, but usually we can create for one container, one pod only. Mm. So let's take. So this is the pod definition, guys. If you want to create a, this is the pod definition.ml. So here everything we can easily understand, right? This is what kind is pod. I'm creating a kind. API version is V1. I'll discuss. API version V1 means API server is there now in the background control plane. That is the metadata means what? Pod name. Once you apply pod, which pod will create on which name? And container. So container name, Nginx, and image. This is the image we are calling. Running on which port? 80. Okay. So okay, leave it. How to write? I'll explain tomorrow. Leave it for this. So we can focus on the concept now, not how to write a YAML file as of now. So let's give here vi pod dot YAML. Okay. So command to run a pod kubectl apply -f pod.yaml. File name apply. Okay. Whenever you can apply, guys, how many pods will create now, guys? One pod will create. Kubectl. How to check? Get pods. See, one Nginx pod is running, right? Okay. Okay. So one pod is running. Okay. Now, kubectl apply -f pod.yaml again. What will be the result now? Already simple unchanged, right? Unchanged. Okay, these two use cases we can take and we can try to understand the architecture again. Clear now, guys? Okay. Where is that? Yeah. If you can see here, this architecture, whenever you can apply pod.yaml here, okay, request will go to first where? AMI. Request will go to AMI first. Sorry, API first. API first. This API will request redirecting into where? etcd. etcd inside no information is there for this metadata. Cluster information not there for this pod related information. Then etcd give back to the API. API will check with the scheduler. Scheduler will give information back to which node inside. Here controller will miss. Why? This is simple pod only. We are not using replicas and all, right? So controller will miss here. Okay, no desired state and current state, right? So, okay. So pod controller only will work anyway. And next API will request redirecting into where? Worker node. Which worker node? Scheduler decided worker node, kubelet. Kubelet will pass the information to container runtime. Container runtime will create a pod and give response back to kubelet. Kubelet give response back to API. API inform to etcd. Again API inform to back to you. That's what you can see here. Pod created. So API given information back to you, right? Again, if you apply same job again, API will take the info and check with etcd. Etcd will give back, no, this pod is already running. This information already stored before. That's what unchanged. Clear now, guys? Okay. Let's go to vi pod.yaml now. Nginx Y. Oh, no. I'm doing, I'll tell you. So, guys, interesting part. MV pod.ml to pod1.ml. ls. Now tell me, kubectl apply -f pod1.ml. Unchanged or changed? Unchanged or create one more pod? Think and tell me. Naresh, wait, I'll discuss. Wait. Slowly we can discuss. Create one more pod or existing pod only? Unchanged. Many people saying unchanged. Yeah, Rajesh saying create. Okay. Guys, tell me one thing. Pod.ml file name will be stored in etcd. Okay. This file will be stored into where? Pod.ml file will be stored on where? Guys, ls. This pod1.ml is stored into where? Server inside. Which server? Client server, not etcd inside, right? Whether you change or not doesn't matter here. Inside pod name is same or not. Metadata means what? Not file name. etcd inside, it's a database. etcd is a database, stores the information key value pair. So which pod name, everything will be stored inside the etcd, not file name. File name will be stored inside the server, client server, right? Even if you change, request will go to where again? etcd. Start, Start. Okay. Okay, yes, kubectl apply just wait guys, please. Here. Okay, let's refresh again. Yeah, perfect. Okay, yes. Okay, ls. So pod1.ml is there now. Kubectl apply -f pod1.ml. See, again unchanged. Clear na guys? AML name only you changed. Not inside metadata information. etcd inside stored metadata information, not your AML file name. Clear or not? Okay, let me tell you one thing. If I delete a pod1.ml, pod will delete or not? No, you are deleting AML file from the Linux server only, not deleting a pod. Understand the difference here? Yeah, very good. Now pod name, I'm going to change Nginx Y. Okay. Don't change image name. Nginx Y image is not there, guys. I'm changing only pod name. This time, creator unchanged. Request will go to API. API will say, this is the YAML file information. etc will check, no, this pod is different. This pod is different. Maybe this is new requirement. Then ask to scheduler. Scheduler will decide it. And scheduler will confirm which node. The same node inside kubelet API pass the information. Kubelet will run the container runtime. Create a pod. Will give the response back to same API. API will give back to us. Created pod. Clear now, guys? Okay. Now, great. Okay. Now I want to know more information about the pod. In Docker container, inspect container to info, get it more, right? So here command is kubectl describe pod. Describe pod, which pod? You can give the pod name. Kubectl describe pod name. Now you can see, this is the command where I have executed here. You can see here, which node inside this is running. This is the node. And start time and IP of the pod. And you can see next container D, not Docker. Okay. So image ID, image is Nginx. Next. You can check. Yeah, this is important now. Events. Guys, see, first request will go to where? Default scheduler. Default scheduler successfully assigned this node 172.31.23.91 DNS name of the server. After node assign done, pull the image in the same node. Kubelet give the info to container runtime, pull the image and run the image as a pod. So successfully pull the image, third event. After successfully create a pull image, next is what? Create a container. Next is what? Start a container. Start container, ready container. Two states here. kubectl get pods. One by one is there na? One is start container, one is ready container. After start, it may stop, right? 0. 1 by 0. 1 by 0 means what? Container started but not running. 1 by 0, pending state. So many things, 0 by 1 also, container not started. I will show each and every state. Okay. So till here clear na? The events, how it was generated. So scheduler will decide one node. The node inside kubelet, pull the image, run the image, create a container, start a container. That's what pod, how it is created. Okay. kubectl get pods, give information of the pod status, right? kubectl get pods -o wide. If you give this command, you can see more info along with the pod. See, IP of the pod, node information also. Just tell me, two pods running on same node or not? Same node. It may create second node also. If you delete, maybe it will get second node also. Okay. Let's now kubectl get nodes. It will give nodes information. kubectl get nodes -o wide. It will give more information of the nodes. -o wide is means what? More information, wide information. Now you can see this is the server internal IP, server external IP, which OS and all everything we can see of the node. Now you can see this is the node. Your two ports are running, right? 172.31.23.97. Clear or not? This is the internal IP of the internal IP means private IP of the server. This is public IP of the server, external IP, right? So two ports are running into this node only. By giving which command you can see kubectl get ports -o wide, take the node and give the kubectl get nodes -o wide and check the which node it is. Clear na? So these two nodes are here. Don't confuse, this is client server. Yeah, guys. Here you can see 172, 31, 23, 97. Clear na? Clear everyone? This is external IP, you can see. 13, 218, 244, 91. Excuse me. Okay. Now, so guys, if my pod delete kubectl delete pod, give the pod name. This is delete command of pod. Two commands are there to delete. By giving a pod name, you can delete pod deleted. So guys, if pod deleted, immediately one more pod will create or not? My pod controller is not replica set. There is no replica sets, right? So it will not create. Delete only. If you delete only. Cubes, it will get pods. One pod only there. Nginx pod deleted. So delete process is what? So focus is delete focus. Delete process. kubectl delete pod name. Or we have another method also. Delete process. kubectl apply -f file name is there na? Quite opposite. kubectl delete -f pod1.yaml. In place of apply, we can delete na. Whatever pods created by using this YAML file, all are deleted. To second method. Clear na? Okay. Clear na guys? Okay. So now delete is done. So again, you can create kubectl apply -f pod1.yaml. Now pod will create on which node? Any node, right? See, it's a scheduler call. Scheduler call, no? So again, it is created on same node, or maybe same node. Clear na? So this is, guys, tell me, can I deploy my application through pod.yaml now? Is it recommended? So not recommended. Why? Why not recommended? Pod.yaml is why not recommended. If it will delete, complete application will down only. This is lightweight, anytime can delete. In this case, if you deploy your application inside the pod.yaml by using a pod.yaml file, if pod is deleted immediately, application also down. Understand? It's not high available to create a many pods. So this is not recommended to deploy applications. The reason is what? No controller to give many pods to get high availability. If pod delete, complete application down. So next we have two options: replica set, deployment. Let's see. So guys, replica set is a controller, guys. Whatever things missing inside the pod, what we mean is replicas. Only one pod only creating, right? I want many pods to balance my traffic. Like autoscaling, creating multiple servers, right? Single server is not recommended to deploy your production application, right? Server may stop or server may delete, application will down. That's what we are doing. We are configuring autoscaling group to configure the application into multiple servers to scale up and scale down based on the number of requests are hitting. So here also, I need a scalability, high availability for my application. Then pod is not a recommended YAML file as it is not providing any high availability actions. In this case, we have a options to replica set or deployment. Let's go with replica set. So what things can be added on the top of the pod here? Let me show you. This is podded ML, right? What we done now. Let's take here. This is pod. What missing things are here? Replicas. Replicas are missing here, right or not? So how many pods will create? One only. But we can overcome the challenges, high availability, scalability point of view. We can create one more method is replica set.ml. I'll explain tomorrow how to write and all. Very easy. Now by seeing this, okay, let me explain now also if required. Hmm. Guys, here, which type of AML it is? That's what kind is replica set. API version will change here. Apps v1. For pod is v1. Here metadata means what here? Which name? Replica set name or pod name? Replica set name. This is replica set entry here. This is replica set name, guys. Here, why kind is pod? Clear now? Specifications. Which specifications these are? These specifications are can I say pod specifications? This name is, can I say pod name? I'll tell you what about labels later. Clear na? Pod metadata name, pod specifications. Now coming to here, I'm talking about replica set. This is replica set metadata. These are replica set specifications. Replica set, what it is giving? Replicas. That's what replica entry is there here. Clear na? This is what missing here, right? Now if I run replica set.ml, how many pod will create? 3. Clear na? So, okay, let's wait now. This till here replica set entry, right? Till here replica set entry. What about this one? By seeing this, what you can understand? No. Seeing this, which YAML file this is? Pod. Clear or not? See, same. You can see this pod inside. What we are adding here? Replica set to give a more replicas. Clear na? So this is missing before. I'm adding into the pod on top of the pod now. Hey pod, now you can run 3 copies. But important condition you have to understand. How many labels are there here total? Labels. Here how many labels are there, guys? Label entry is 1, but labels are 2. Key name, key value, key name, key value. App equal to web app, country equal to India, color equal to blue, type equal to front end, anything you can write. Key name and value. Okay. So labels entry 1, number of labels are 2. Here how many entries are there for labels? 2. One is for replica set label, one is for pod label. The condition is replica set label should match with pod label, at least one. Clear na guys? See. Replica set label is what here? Pod label. So pod labels are 2, replica set label is 1. Condition is what? At least one pod label should match with replica set label selector. Replica set label selector is app, web app. One pod label is matching or not? So one pod label is matching here and here. At least one, not all. Only this replica set will work. Understand? Replica set labels, pod labels completely different now. Communication will be break. Replica set will not apply effective on the pod level. It's not apply. Clear na? This is what now? Pod space. This is enter pod, guys. Only the additionally adding is what? Replica set entry, replica specifications. Let's go on now, run. vi rs.aml. Name your wish. You can give anything now, guys. kubectl. Already mind any pods are there? Nothing. Oh, kubectl delete pod nginxy. Mm. Okay, I'm going to apply now. Clear na, guys? Now, how many pods will create? 3 pods. All are created same time. See, 10 seconds, 10 seconds, 10 seconds. Okay, so how to check replica set information? Everything command is kubectl will get only. So you are going to check replica set information, right? You can give rs only. See, desired count is 3, current count is 3, ready state also 3. Now, so in our architecture now, controller also there. Which type of control this is? Replica set controller. Okay. Now see here. Yeah, now you can see. If I kubectl get pods, how many pods I can see? 3. The name of the pod you can see web replica set pod name, web replica set pod name. Why? Name, metadata name. WebRS is the replica set name. It is linked with pod name. I'm going to delete one pod now. Clear na? One more pod will create or not immediately? Because of replica set controller. See, within seconds, not fraction of seconds, pod created. This is the new one. You can see the A 7 seconds ago. Okay, now coming to the architecture. Architecture, whenever pod deleted, what happened exactly here? Request will go to where? First kubelet will notify to API, one pod deleted. API will inform to controller, one pod deleted. Controller will check with etcd, take the information, apply the desired state and current state. So one pod only, deviation is that pod is running. Clear na? Okay, let's go now. Okay. So now I want to delete. Okay, I'll do one thing, guys. Again, there is a drawback here also. I'll explain that now. So here, if you want to increase the pod count, you can increase also rs.aml. So this time, existing pods 3 and one extra replica have added, right? Now 4 pods total. Additionally, one pod will create or delete 3 and create again 4 because of etcd. Clear na? Now controller inside desired state set point will be changed now. 4 now. Clear na? Okay, so clear na till here? This is called self-healing concept. Self-healing. Kubernetes controller by default enable self-healing to maintain the desired state and current state. No auto scaling group is required here. Clear now? Okay. And now I want to delete. Okay. The main drawback for the replica set, let me explain. Na? So VI focus here, very important. The drawback of the rs.ml. Insert. Guys, here, which image I'm using here? HTTP image, right? I insert. I'm going to change now HTTPD image to Nginx image. Complete image changed. Expected response is what? Delete and create, or running time only OS will change. I mean, image will change. Delete and create. Clear until here? Okay. This is what we are expecting. Image version change. New changes pushed by developers. New Docker image will build and push into ECR. You can take the new image only, right? New offer image you have to process. Old image, okay. Now in this case, configured. Okay. Let's check now kubectl get pods quickly. What happens here? See the age. Any new pods created? Any pods deleted? No. So what I can understand here, I have changed my image, new version will build here. But what happened exactly? Still old version only running. How to confirm this? Kubectl describe the pod and check the scheduler inside which image is pull or not again, right? Okay, let's take now. Kubectl describe pod. You can take any pod name. I have changed it to which image, guys? Nginx. Still previous image only. I mean, no action perform here. After run your kubectl apply -f replica set.ml, no action will perform here. Clear na guys? When this process will allow kubectl get rs replica set, right? So how to delete the replica set now? Two options. Through file kubectl delete -f replica set.ml, or kubectl delete not pod. If you delete a pod, again pod will create na. Kubectl delete replica set and give the replica set name. So webrs is what? Replica set name. Either you can delete kubectl delete rs, give the webrs is the replica set name. If you delete pod, again pod will create same auto scaling concept only, right? Auto scaling group created a server. If you want to delete one server, auto scaling group again create a one server. So you have to delete auto scaling group only. In this case, this command also fine, or use the same ML which you created replica set, give kubectl delete -f replica set.ml. Clear na guys? Okay, what is the main drawback of the replica set? First advantage is what? The drawback from the pod, we have implemented the replica set to give a number of replicas, high availability, self-healing and all. But still, we are facing one drawback. The drawback is what? Upgrades. Image upgrades not possible by using replica set. But now if I apply, see guys, which image it will take now? Now Nginx it will take. But modification is not possible. When pods are running, replica set not allow for the image modifications. Delete and create only. But delete and create is not recommended now, right? If you delete, pod inside application is running na. If you delete, pod also delete, application also down na. So why should I use this replica set concept? Right or not? See, 33 seconds. Which pod? kubectl describe pod. So this time Nginx is taking. So delete and create only, it will work. If you are using a replica set, if you want to upgrade the image, so first delete, then create only, it works. But this is not recommended. One advantage is what? Self-healing is possible, which is not possible in pod. Okay, some drawback we can easily overcome by using replica set. But one more drawback is what? If developer push the new changes, new image not update, image update is not possible, delete and create. So we can simply ignore this concept as of now. Clear na guys? So final work node component is what? Kubectl delete rs web rs. Clear na? Okay, so next, this one also drawback is there. Drawback is what? Image rolling update. Update not possible. We have to delete and recreate only. So, but this is not recommended, right? So final option is what? Yeah, this is actual one. Okay, let's go and check it now. VA deploy.aml. Guess no change. AML file, no change. Just change deployment. That's it. Understand? Deployment controller will create. Now, which controller is using? Cluster inside replica set controller that you can replace with deployment controller. That's it. Same AML file. No, not even single change. Clear na? So, copy. I'll explain tomorrow how to write AML files. Nothing to worry. Okay. Total. Okay. kubectl apply -f deploy.aml. kubectl get pods. Three pods are running right now. 14 seconds ago. Whenever you can run deployment also, replica set also will create along with the deploy. Kubectl get rs, you can see. Clear na? This replica set will give the replicas to deployment. Kubectl get a deploy. No need to type deployment. Just get a deploy. You can see deploy information also. Clear na? Up to date. Out of 3 pods, 3 are up to date. Okay. Now the drawback of the replica set is what? Image updation is not possible. We can open. Insert. So which image I'm using? HTTPD. Let's change to Nginx. Clear the difference now? See the A's here. And one more thing is all pods not deleted in same time. Observer not here. So one pod deleted 6 seconds, 8 seconds, 10 seconds means rolling update. One pod delete, one pod create, one pod delete, one pod update, one pod delete, one pod update. Clear na? So now you can see here kubectl describe pod. So you can take the pod name here, copy here. See Nginx image pull, right? So if developer push any new code, automatically Jenkins will build a Docker file and new image will push into ECR. New image will run as a pod. New changes will effectively apply, right? Without any downtime for the deployment time. But same thing if you deploy in the pod will create. Application will run, but no high availability, no self-healing feature for the pod. After that, we can overcome by using the self-healing concept by implementing a replica set. But again, we have some drawback. Image upgradations are not possible. So that finally we can go with deployment at ML. Clear na concept na everyone? So Kubernetes main repository is there in the GitHub. You can go through it. Installation part, if anything is required, day one, and day two is the worker node. So I'll explain tomorrow. AML files, nothing to worry. So clear the concept now, right? But how to give access? We have to create end users access. We have to create a service concept in Kubernetes. In Docker, we are running -b localhost container target port to give access. We are giving through node port. But coming to the Kubernetes, we have a many options. Services concepts, load balancer access we can give now. Easy way. Having a 3 pods, right? 4 pods. We have to create a common endpoint, that is load balancer. You no need to create any load balancer manually. Create a just 6 lines of the YAML file service.yaml. Apply. Immediately load balancer will create in your AWS account inside. Clear now? Now process is very easy to deploy. You no need to follow many things manually to create a load balancer and auto scaling manually the things and all. Very easy. Any questions from anyone? So we discussed more than 10 commands today. So practice. You can practice in the cluster inside or also simple. You can practice here also. Easy way. Killer code here directly you can apply YAML file. Same command, same process. This is free environment. But the drawback is if you want to this is not AWS environment inside, right? A few things are there. 10 to 12 classes you can practice killer code inside. Remaining you can practice in the AWS environment if you are using a pre-tier environment, I'm saying. Any questions from anyone now? ETCD full form, huh? Let's check. Still you are thinking. Note down. Everywhere is not mentioning. ETCD is a open source distributed key value store used to capture the managing the critical data system needs continuous operating. Pronounced ETCD. Okay. Why you are asking this kind of questions, guys? See, many people are worrying now. They're busy with checking ETCD. Final item. This weapon will give. I think I think already many people search and they have shared. Oh, elastic tree configuration database. Nice. Is it right? Enhanced tree comparison and differentiating. I don't know. Many full forms are there. Okay. Correct name you can share into the group. Okay. So any questions, guys? Okay. So whoever asks etcd full form, you can check what is full form of Kubernetes. Thank you so much.